If you're a homeowner planning to add an in-ground swimming pool, whether you're looking to hire a pool company to handle everything or you're a do-it-yourselfer, you need to understand the difference between Gunite and wet shotcrete, the two most common methods used to form the most critical and expensive part of the pool, the shell. While they're certainly similar, there's a lot of misinformation floating around, claiming there's no big difference between the two. When the truth is, one reliably results in high-strength concrete throughout the entire shell, with all pool designs in all climates and conditions, while the other is a risky gamble, far more likely to result in a substandard shell, which can mean a nightmare for the pool owner, usually meaning significant repair costs and sometimes requiring total reconstruction of the pool. Gunite and wet shotcrete are both pneumatically applied concrete. Concrete shot through a hose and nozzle at high velocity, which packs and compresses the concrete for increased strength. And actually, they're both technically called shotcrete, one being wet and one being dry. But that can be confusing and misleading, so the term Gunite is instead often used for the dry method, while just shotcrete typically refers to the wet mix method. The key difference between the two methods is, with shotcrete, the concrete is entirely pre-mixed, including water, at a concrete batch plant, and transported to the job site, usually in ready-mix trucks like this that keep it agitated. Then at the job site, the mixed concrete is pumped through the hose, and finally compressed air shoots it out of the nozzle. While with Gunite, on-site mixers like this are used, and the base materials, sand and cement, are kept separate until shooting begins, when they're then mixed together without water, and that dry mix is sent through a special feed bowl and blasted through the hose with compressed air. And the water isn't added until just before it's shot at the nozzle. And this difference is huge, because it introduces a lot of uncontrollable variables with shotcrete that can significantly diminish the strength and integrity of the pool shell. Variables that just don't exist with Gunite, especially with the latest Gunite equipment available today. This isn't to say that wet shotcrete is incapable of producing a quality shell. Under ideal conditions for timing, job coordination, and temperature, with a relatively simple pool design, shotcrete can produce a quality pool shell that'll have a long-term strength you expect. But in everyday real-life conditions, the odds just stack against it. To put it another way, not every pool shell formed with wet shotcrete will eventually crack and fail. But when a pool shell is cracking and failing, it was most likely formed with shotcrete. And here's the fundamental reason why. When the concrete materials, aggregate and cement, are mixed with water, instantly a chemical reaction called hydration begins. Basically, the concrete immediately starts to set or cure. The clock starts ticking to apply the mixed concrete before it hardens. Industry experts and engineers all agree that the maximum time from mixture to application is 90 minutes, and this is shortened to as little as 45 minutes in warmer weather. So when the wet shotcrete is mixed at the batch plant, the clock starts right then. And of course, the ready-mix truck has a first travel from the batch plant to the pool job site, where several factors like driving distance, traffic conditions, driver discipline, and navigation can all affect how long that takes. And once the truck arrives at the site, often the truck has to wait, for example, for a previous truck's load to finish being applied, and then there's usually a lengthy setup time before shooting actually begins. Numerous variables exist that can easily mean well over 45 minutes before the truck's load even starts being applied. Then there are several factors that affect how quickly the entire truckload can be shot, like the size and complexity of the pool design and contour, the speed and efficiency of the crew. And with wet shotcrete, if the job has to stop for any reason, from mistakes in application to equipment failure, each time the entire hose has to be cleaned out before shooting can resume. So what ends up happening, far more frequently than you'll hear anyone in the shotcrete business admit, is the concrete becomes hot. It starts to thicken and harden before the entire load has been applied. Sometimes even before a whole truckload has even started being applied. Industry standards clearly dictate that at that moment, all the remaining material is supposed to be immediately rejected and replaced with a fresh batch, even if it's an entire truckload. But that, of course, is expensive, in both time and material cost. And come on, it's just a swimming pool, right? So instead, the shotcrete crew will take shortcuts, adding more water to the thickened concrete so that it can be pumped through the hose and shot, or even applying the remaining material by hand with shovels and trowels, both of which are terrible for the finished concrete structural integrity. The more water that's added to concrete, the weaker it becomes, which is exactly why such concrete is supposed to be replaced, not watered down and used. And shotcrete has to be shot at extremely high velocity for necessary compression and consolidation. Application by hand reduces the strength by as much as 80%, even when more water hasn't been added to the mix. But with Gunite, transit time doesn't matter. The distance to the job can be 200 miles. There can be bumper-to-bumper traffic en route, and the driver can get lost, or even stop for lunch on the way. And when the truck arrives, it doesn't require perfect timing with the crew or other trucks, and can wait as long as necessary. The materials aren't mixed until shooting begins, and so it doesn't matter how long it takes to start shooting. And even more important, the water isn't added until the nozzle, an instant before it's shot onto the pool structure. The hydration reaction begins right as it's applied. Plus, because only dry mix is sent through the hose, it doesn't require cleaning if the shooting has to stop for any length of time. The job can stop and restart as many times as necessary, without the crew racing against a chemical reaction that can't be stopped. And this is an important point, because with both Gunite and Shotcrete, the workmanship of the crew, especially the nozzleman, is crucial to the quality of the pool shell. And when the crew can take the proper time to ensure the application is flawless, rather than rushing to beat a clock with unknown time remaining, more often than not this one factor alone will result in a far superior structure. Also, because the water is added at the nozzle, right at the moment of application, less water is needed with Gunite than with wet Shotcrete. And with Gunite using less water, that alone makes for stronger concrete. But it's also lighter with much higher nozzle velocity, resulting in better adhesion, bonding, and compression, so that it can be properly shot on just about any contour or structural feature of any pool design. Many contours where the heavier wet Shotcrete will tend to sag or fall off and require application by hand. Now, many of those in the wet Shotcrete business will say that Gunite has its potential problems also. One being that the nozzleman is in control of the water flow, so there's no guarantee that the water ratio is within acceptable range. And that there's no guarantee that the sand and cement are mixed at the proper ratio. Unlike with wet Shotcrete, they'll say, that's mixed at the quote, perfect ratio at the batch plant. But this argument is as weak as watered down Shotcrete, because with too little water at the nozzle, the material rebounds after it's shot, becoming high-speed projectiles flying back at the nozzleman. And with too much water, the concrete sags and doesn't stick. With Gunite, proper water ratio simply makes the nozzleman's job easier, which is far more dependable than with Shotcrete. As far as mix ratio of sand and cement goes, absolutely it's important. Proper mix ratio is another crucial factor in the structural integrity of the pool shell. But first, why is it assumed that all batch plants create perfect mixtures every batch? The truth is, the homeowner has no guarantee and no reason to assume that the ingredients or mixtures in the ready-mix trucks are perfect. But this is really beside the point, because today there's Gunite equipment that automatically meters and measures the materials as they're mixed, ensuring the proper mix ratio throughout, and automatically reports all of the material and delivery details in real time as the pool is being shot. With the smart Gunite system precision mixer, you know not only the mix ratio, but the total material delivered, minute by minute, with a certified material delivery report available after the job is complete. So whether you're building your own pool or hiring a pool company, don't make a high-stakes gamble against the odds. Make sure your pool shell is formed with genuine Gunite, and with the precision, transparency, and peace of mind that can only be found with smart Gunite.